Same model, same prompt, different answer, 50% of the time, on NVIDIA's own format. One setting is silently breaking tool calls, and it's not the one you'd guess. This is NVIDIA. Its chips run most of the local AI boom right now. Its newest low-precision format, NVFP4, just got tested head-to-head against INT8, official FP8, and AWQ4-bit, all measured against a full-precision baseline. One tester's verdict was blunt enough to become the format's actual nickname in the write-up: FP4 is a lie. And this is vLLM, the open-source engine most local inference actually runs on. The tester pushed identical weights through 3 of its attention backends, Flash Attention 2, Flash Inference, and Triton, plus 5 separate quantization methods. Same weights, different backend, different answer every time. The tester opened with the actual thesis, quote, "Every single instance of hardware and software running an LLM today is a little bit different." Picture the actual test. One model, one prompt, configure a router interface. On one backend, flawless. On another, it confidently writes the wrong interface and hands it to you like nothing happened. The wrong answer, Gigabit Ethernet 0/1/4. The real interface was completely different, 0/0/1.201, silently wrong. One tester actually proved this in public with receipts. Forum user THR3E ran the comparison and opened with a verdict I can't top, quote, "Your local implementation sucks. But that's okay, everyone else's does too." Hacker News picked it up fast. 417 points, 171 comments. Real people, in the replies, posting real numbers, 17 tokens a second on an M3 Pro, thrilled with setups that might be failing the exact test above. And there's one exact combination that passed every single test. That's coming, stick with me. Lay the 2 results side by side. INT8 closed every tool call correctly, every single time. NVIDIA's NVFP4 hit roughly 50% token disagreement by the time context filled up. Same benchmark, opposite outcomes. Let's look at the mechanism, because 3 separate places are quietly leaking precision. Read the actual setup. Quote, straight from the post, "There are 3 available full attention backends to select from in vLLM for this workload. Same weights, 3 different math paths." The divergence isn't smooth either. Token flips cluster worse on certain prompts, not just longer context. Same weights, 3 answers. Pick the wrong backend and you've quietly picked a different model, one you never explicitly chose. Then there's the memory cache. Quote, "Int8 KV cache eventually managed to recover. Int4 did not. 1 digit of precision, the gap between a glitch and a broken session." That setting from the top, KV cache quantization. Drop it to 4-bit and recovery just stops. It stays broken. Watch it happen live. Quote, "Both NVFP4 and AWQW4A16 failed to properly close their tool calls and botched the command syntax. Full precision and INT8 closed everyone cleanly." The tester's own ranking, in their own words, INT8 mops the floor with everybody, including NVIDIA's FP4 is a lie release. That nickname isn't mine, it's the tester's, printed right there next to the actual benchmark numbers. Read it yourself. Meanwhile, on the same thread, people are thrilled. 20 tokens a second here, 13 there, 25 on an M5 Max running unsloth desktop, 59.5 on a maxed out Mac. Nobody's checking which backend actually shipped the answer. And the hardware feels it too. One user logged their GPU hitting 95 degrees, fans maxed, just running this locally. So the actual ladder, top to bottom. Full precision is the baseline. INT8 passed everything. Official FP8 passed. AWQ 4-bit failed its calls. And NVIDIA's NVFP4 landed dead last of all 5 by the tester's own count. Time for the honest twist, because nobody's actually claiming malice here. To be fair, no lawsuit, no ruling, no proof anyone did this on purpose. This could be completely ordinary variance. Even the thread has real believers. One developer, quote, "Honestly, I'm pretty blown away by how not dumb it is." Fair, but blown away isn't the same as verified. Now, let's be honest. Most people running local models never hit the worst combination. Plenty of setups pass every test fine. Running hot, running slow, eating your battery. Real costs too. One user logged their context window practically maxing out past 32K, even set to 64. Too much swap and slow down. That's not a benchmark chart talking. That's someone's actual Tuesday. And even the winning setup here is still quantized, not full precision. Nobody's saying go back to renting. And the other option isn't free either. One commenter's real receipt. Renting a cloud GPU instead runs about $2 an hour. Lay the two options side by side. Rent a cloud GPU, and someone else quietly picks your backend for you. Run it yourself, audit it yourself, and nothing's hidden from you. Nobody in that thread actually asked the obvious question, which setting is on by default? And so far, no public word from NVIDIA either. One more honest line, same thread, quote, "It's a big wow factor to get a non-trivial LLM running on my Mac, but it's actually not that useful. Ouch. And also, fair." Here's the honest number, though. 0, that's how many popular local tools show you the backend by default. Most just say quantized and stop. So let's audit the stack, the exact combo that stayed honest, and how to check yours. The combo I promised. INT8 weights, paired with full precision, or INT8 KV cache. In this test, it's the only setup that passed every single tool call. Don't take my word for it, check the source yourself. Quote, printed plainly in the thread, INT8 KV cache eventually managed to recover. INT4 did not. 3 real moves straight out of this comparison. 1. Find out which backend and quant format your setup actually runs. Check the startup log. Most tools don't show you by default. 2. Don't default to the newest low-bit format untested if you're calling tools or writing commands. 3. Run one real task on 2 backends and actually compare the output, not just the speed. Same thesis this channel keeps landing on. Verify what's running. Don't just vibe with a benchmark chart. So, to recap the whole pattern, top to bottom. NVFP4, roughly 50% token disagreement at max context, the worst of 5 methods tested. 3 attention backends tested on identical weights. Only 2 of 5 quantization methods passed every single tool call, and 0 official response from NVIDIA so far. 1 of 5, that's how many quantization methods passed every single test in this comparison. Check yours before you trust the chart on the box. Yesterday, this channel covered Claude Code, changing its own settings without telling anyone. Today, it's local AI quietly changing its own answers. Own what you can verify.